Right, this is the end of topic test question 3. First one we're asked to graph is this. Now I know that's the graph of a quadratic, and so the shape of the graph will be a parabola. It's all positive, so I know it should end up looking like that. You might remember that when a parabola is given in brackets like that, it's translated horizontally, sideways, and this one in fact would go back, and so where the parabola normally sits on 0, 0, it would go back to sit on -2. We've talked about the shape, across 1, up 1, across 1, up 1, across 2, up 4, across 2, up 4 to give it shape, across 3 places from the vertex, 1, 2, 3, and up 9. So if we were to join this up, it's going to look like that. So that's one way to do it, knowing once you know where the vertex of the parabola is sitting. Now for those of us that forget the rules and forget how it moves, you can just do a wee table of points, x, y. We'll do our usual -3 like that. You can work it out in your head, of course, or you can come over to the calculator. We'll do a table of points. So we're going into table. We'll put the rule in. It says y equals, bracket, x plus 2, close the bracket, square it, execute. We need to set that. We'll set it to go from -3 up to 5's all right. And looking down I can see the y values 1, 0, 1, 4, and we could get some more, 1, 4, 9, 16, and so on. So plotting these points, -3 goes to 1, -2 is 0, -1 to 1, 0 maps to 4, 1 to 9, 2 up to 16, and once again we have our basic parabola. Try and get it as close as you can through the points, and perhaps show a bit more with the symmetry showing through. Right, next question, onto a practical one. So we've got an equation there, and we'll write it out and put the time signs in, because it always looks a bit complicated. -0.2 times x times x minus 7. Now I know some things when I look at that. I know that one of the x-intercepts will be at 7 and the other one will be at 0. The x-intercepts are at 0 and 7. Right? Let's assume that we didn't know that and you can't remember that. Then you could come over to the calculator and we'll think of a way we could do it on that. To find features, things like intercepts, we go into the graph menu and the equation comes, oh no, that's the old equation, so we need to delete that. So let's put in this one, -0.2. And of course it's not working very well. -0.2 times the x value times bracket x, and the bracket didn't come out, x minus 7, close the bracket, and the 7 didn't come out. You need to press very hard on this, and we'll ask it to draw that. Now we're probably going to have to play around with the view window so we can actually see the picture, so remember to come up to view window. Having a look at this, obviously the x-axis first, x minimum. I can see that 0. We might just go beyond that and we'll try going from -5. Now we need a maximum value. I know that that's going to be 7. If you didn't, you could try something like 10 as a starting point. And we'll go down to the y-axis, once again 0. We'll just go a bit below that. We'll try going from -5 We need a maximum value. Now that's a lot harder. These numbers aren't big. I don't think there's any reason to try 100 or 50 even. You might try 20 at a start. Let's see if we can see the graph now. And I can. The y-axis is a bit too much, isn't it? So we'll go into the view window and let's change that y-axis. We don't need to go up to 20. That was far too high. We'll change it to 10. Just so I get a better picture. That's even still too big, but it's looking better. Now if we want to find the x-axis, the answers to life, the universe and everything are under G-solve. Now it doesn't say x-intercept along there. You might remember that the word is root, used to describe the x-intercept. So if we touch on that, I can see one of them is at 0. Back over here, and we'll use the arrow key to move along to the next one. X equals 7. So while we're here with the graph, we might just find out that maximum point, because that will be useful as well. So if you go back to G-solve, and we could ask for the maximum point there. And it's found it for us. Of course, that value is 3.5, halfway between the 0 and 7. And if we get the height, 2.45, in case they ask us for that later. Right, so the x and y intercepts. X-intercepts need to be clear what it is you're finding. They should be coordinates. 0, 0 for that one. And next coordinate for that one, 7, 0. Looking for the y-intercept. Oh, and once again the y-intercept, 0, 0. Now part 2, what is the maximum height of the tunnel house? Well, we've already solved that, because I can see the maximum height is up here at 2.45 metres, the maximum height. Remember the unit. Right, strengthen the tunnel house by putting a horizontal brace from one side of the tunnel house to the other side at a height of 2 metres above the ground. How long do we make the brace? So 2 metres above the ground, so that we'll estimate that. We'll change colour to show we're answering a different question. We're going to put the brace going from there to there, and we want to know how long to make the brace. Right, this is a fairly tricky question. We can do it on the calculator easy enough, but we need to show some working if we want to as well. First of all, we'll do it from the calculator. So this is part 3. I'm going to start answering it here so I don't have to go backwards and forwards, but you should do it in the space for part 3. So using the calculator, I'm going to draw a line across at y equals 2. That will give me that line there. If we do it back over here, so if we put the line y equals 2, just a straight 2 there, that's y equals 2. And we graph that on the same one, there we go. Now we want to find out where those intercept. Of course, all the answers are under G-solve. Looking along the bottom, I would choose intercept. One of the places that it intersects there is at 2, 2, so that's x equals 2. We could use symmetry to find this as well, or we can come back over here, and obviously it's going to be at 5 over here. So the length of the brace, 5 minus 2, is 3. You could write down the length of the brace as 3 metres. But doing it with some algebra, you might want us to, it says to show all working in any equations that you solve. We want to solve and find out where this equation which is the equation negative 0.2x x minus 7, we want to find out where that equals 2, where it has a height of 2 for which x values. Right, it's not easy. We would start by expanding the brackets, negative 0.2x squared. Now when we multiply those two terms, two negatives make a positive. I'm going to need the x term, and I'm going to need 0.2 times 7, which is 1.4 equals 2. Negative 0.2, we always get 0 on the right hand side if we're solving a quadratic. I can see this is a quadratic. Not an easy one to solve. There are some things we can do to help ourselves here. If we want to have this as a whole number, one thing we could do is times everything by -1. Timesing by -1 will change it to positive, at least at the front. That sign would change to a negative and that one to a positive. Now the other thing I'm going to do, because it's very hard to factorise at this stage, that 0.2, I want it to be 1x squared. Now I know that timesing by 5, 0.2 times 5 would make that 1x squared. 1.4 times 5 is actually 7, which is nice. And 2 times 5 is 10, so that's now my quadratic, which I'm ready to factorise. I'm just going to go back here because I'm running out of room. Factorising that. 2 and 5. 2 times 5 is 10. To get -7, they'll both need to be negatives. X equals 2 or 5, which is what we got originally. Therefore, the length would need to be 3 metres, and you can write a proper sentence, but I've run out of room. I understand that's very difficult. You can of course just do it from the graph. A correct answer only would be fine for achieved. So writing up the top there that the length is 3 metres just by using your graph would probably be enough for achieved. Right, have we finished that one? Done that question. One more to go. First 4 seconds are in a straight line, so we've got that point definitely and that one, and the rest is parabolic. Give the equation for the first 4 seconds, so that's the equation of that line. We'll go back into red. It's a straight line, so we need y equals mx plus c at the moment. The y-intercept I can see they've told me there is 23 plus 23. We need a gradient. Helping ourselves, rise over run. The gradient will be, now we need to know that rise. This value is 63 minus 23, so that would be 40. You can write on the graph. And the run I can see is 4. So 40 divided by 4, which equals 10. We'll try and use the lettering that they're using on their axes. So instead of y, we're using h for height. 10 times in x is the time, they're using t plus 23. So that will tell me the height anywhere in that first 4 seconds. Right, give the equation for the rest of the objects travel, the parabolic part. So that's going to be the parabola. Now, we've got 2 points. For a parabola you need 3, and it's probably quite important that we use symmetry to get that exact point. Obviously the height is 63 of that point, and you can see using symmetry that the x coordinate would in fact be 8. So for my parabola I have 3 points. This point here, which is the point 4 on the x, 63. We've got the maximum, which is the point 6, 75. It's fairly clear that it's 75. And the last point is 8 and 63. So over to our calculator. We want stat for a rule, and we'll enter the points 4, 6 and 8, and the y values 63, 75 and 63. Right, hovering over F1. Now it's a parabola, so we need to choose x squared, and up comes the information. So parabolas look like y equals ax squared plus bx plus c. Using the lettering that they've used again, instead of a y we use h for height. Now the value of a was -3. X we're using t. Let's check B. B is 36. And C is minus 33. The negative is good because it's an upside down parabola, so we'd be expecting a negative value. It's negative. At what time is the object 27 metres above the ground and falling? So 27 metres above the ground. So if I use a different colour, 27 is just about there. Now there's two places 27 metres, one is there and one is there, but the question says 27 metres and falling, so they want this one here, the x value for that one. It looks about 10. Once again, we could have a go on the calculator and graph that line, y equals 27, graphing along with the equation of the parabola actually that we've just got. So if we come over to menu and we'll choose graph, and we'll put in the equation of the parabola, so negative 3 times x squared plus 36 times, and we're using the x, minus 33, we'll enter that one, and then we'll put a line across at y equals 27 as well. Now we can almost see that. We might just check the view window. X-axis, we want to go from 0 up to 12. The y-axis, of course, we want to go from 0 and a bit more than 79, we'll go up to 80. Right, I can see it very clearly. So it's this value over here we want. The answers to everything are under GSolve. Intersect, find out where the two intersect. That's the first one, and the second one over here. So it is actually in fact right at x equals 10. So if in doubt, for an achieved answer you could write when t equals 10 seconds. We'll practice doing some algebra to solve it as well, although it's not easy. Using the equation up here, we want to find out when that equals 27. We obviously want 0 on the right hand side. Oops. So if we subtract 27, we're going to get negative 60. I'm going to times by negative 1 to make everything, to make the positive at the front. So that will change, and that will change, and 0 times negative 1 is 0. Now they all have a common factor of 3 actually, so we could pull that out the front. 3's into 36 go 12, 3's into 60 go 20, and now I might be ready to factorise the quadratic. Two things that multiply to give me 20, 2 and 10, and to get negative 12 they'd both need to be negative, so 2 equals 2 and 10. Obviously looking back at my parabola, it was falling when t equals 10 seconds. So that's the algebra involved, although of course you could have just written this and you get an achieved for correct answer only. So try it on the calculator as well.